This is Algebra 2 with trig. 4.3, working on factoring. This is when the a value is equal to 1. First day of factoring. An expression that is a number or a variable, or the product of these, is considered a monomial. Examples of those would be like the number 4, or even 3x, or negative 7x squared y. Those are all considered monomials. A binomial is the sum of two monomials. So that could be x plus 3. That could be 3x minus 5. Okay, and a trinomial is just the sum of 3 of them. So often we'll have x squared minus 3x plus 4. Those would all be examples, or this would be an example of a trinomial. It has 3 parts to it. 3 monomials, part of the trinomial. Okay, in the past we have worked on FOIL, where we multiply the first, the outer, the inner, and the last. That produced an expanded form of our trinomial. This would be considered in standard form. Now we're going to work backwards. We're going to take our standard form and we're going to break it down into factored form, what we would say in graphing as intercept form. So looking at this example here, we're noticing that we're looking for 2 values that multiply to be 6 and add to be 5. Over in this expression here, they mentioned that ax squared plus bx plus c is going to be turned into x plus p, x plus q. We're looking for a p and q that add to be the middle number, and a p and q that multiply to be the c number, because when you FOIL, it's the last 2 numbers multiply to be the last term. It's the outer and inner that add together to be the center term. So what I often will suggest is to learn how to make what we call a sum and product table. That's the sum side. This would be the product side. You're going to put down your product number. You want 2 numbers that multiply to be 6, 2 numbers that add to be 5. Since we're multiplying to be 6, we know that the 2 values have to both be positive or they both have to be negative. Since they're going to add to be a positive, then we know they both have to be positive. So my possible products of 6 are 1 and 6 and 2 and 3. 2 and 3 is the only way to add to be 5. The 1 and 6 would add to be 7. So if the leading coefficient is 1, then we're all done. We just take the 2 and the 3 and place them inside of parentheses. It doesn't matter which order you would place that. You can always check your work by doing FOIL. The front gives you x squared, the 2x and 3x gave you the 5, and the 3 times 2 gave you the 6. Let's try some others. So I'm again going to suggest the sum and product table. What multiplies to be negative 18 adds to be negative 3. We know that the signs have to be different because it's going to multiply to be negative 18. The only way to get a negative is to multiply a positive and a negative. We know the largest term has to be negative because it adds to be a negative. There are more negatives than positives, so I know the largest term has to be negative. That helps me rule out some of my options. So I write down what my multiples would be to get to negative 18, and I'm looking for the option that would add together to be negative 3. Well, this is the one that adds to be negative 3. So I know my final answer is x, because x times x gives me my x squared, a positive 3, and a negative 6. That would be factoring this trinomial. So we put down what we want to multiply, we put down what we want to add. We know that both signs have to be the same, either both negative or both positive to get a positive 48. We of course are going to use positive numbers to add to be 14. So I know that my numbers would be 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. All the different ways you can multiply to be 48. There's many of them. So some people would like to just put down parentheses and just plug in numbers into the parentheses. If you can see what the numbers need to be in here, go ahead. You don't need the table. If you like to make an X and write out your product on top and the sum on bottom and plug in your 6 and 8 because that adds up to 14, because that's a little organizer for you, that's fine. Go right ahead. My suggestion is to make this sum and product table, because then you can see all the factors and you don't have to worry about organizing it in your head. You write it down, you keep it organized that way. So our final answer is x plus 6, x plus 8. It multiplies to be, well, I guess in this case these wouldn't be x's, would they? They would be d's, because we have d squared and d. Okay. On this side we have negative 63, we have positive 2. We know that they either have to both, one has to be positive, one has to be negative to multiply to be a negative. The larger number is going to be positive because you're going to add to be positive. So negative 1 and 63. 2 doesn't go into it evenly. Negative 3 and 21. 4 doesn't go into it. 5 doesn't go into it. 6. Negative 7 and 9. That adds to be 2. If you're not good with your multiples, you could use your calculator. You could say negative 63 divided by 1, negative 63 divided by 2, negative, and you get a decimal for that one. So rule that out. Negative 63 divided by 3, or negative 3. Negative 63 divided by negative 4, negative 5, negative 6. Those all give you decimals. Divided by negative 7, that gives you 9. So if you're not good with your multiples, which we would hope to build those skills, you can still work through it. M minus 7, M plus 9. The negative 7 and the positive 9. This is only true since the leading coefficient is 1. Later on, when we have another number in front, we have to do more work to include that with our multiples. Okay. Next we have some special products. This first one's called the difference of two squares. Difference meaning subtraction. Two squares meaning here we are squaring a squared minus b squared. If we have this pattern where we can take the square root of the first term, we can take the square root of the last term, and it's a minus, it has to be the difference. If it's a minus in between, then we can write our pattern in this format. You don't have to worry about the whole making our table and trying to figure out what multiplies to be the last and adds to be the middle. If the pattern is in this format, we have a shortcut. For example, here, if you know the square root of the first term, if you know the square root of the second term, then you can write down x and x with that same term here. So when you FOIL this out, you get x squared, you get a negative 2x, you get a positive 2x, and then you get a negative 4. These middle terms will always cross out, so you're left with x squared minus 4. Notice how the b term isn't there. That's how we started it. This is just a binomial, it's not a trinomial. It's a special pattern that you can use to help you find the factors. X plus 2, x minus 2. Another special pattern, not nearly as important because you could treat this just like a regular problem, and if you treated it the way we did above, you'll still get the same answer. But what we're looking for is, do the numbers fit a pattern? And you really got to be good at looking at numbers and breaking that down. My suggestion would be, can you take the square root of the first term? Can you take the square root of the second or the last term, a and b? And the question is the middle term 2 times that product? So we can take the square root of the first term, we can take the square root of the second term, and the middle is 2 times AB, 2 times those values. If it follows that pattern, then you know you can just go straight up and write a plus b squared. If it happens to be the minus to match that, 2ab, but a minus 2ab, then you know there's a minus that goes inside your a minus b squared. It's a perfect square trinomial. So the pattern over here is to show that x squared can be broken down. You can take the square root of x squared. You can take the square root of 9. Okay, that's not quite good enough yet. We have to test for the middle term. The question is 2 times those two values, which is, of course, 6x, is that the middle term? And the answer is yes. So we're going to take x plus 3 quantity squared. Very similarly, we could do it with the bottom one. Let's try some of these. This one here is the difference of 2 squares. So that means we're going to try, you can probably just do it in your head, but I'll show you my work. Can you take the square root of the first term? Can you take the square root of the second term? And if the answer is yes, then we can go right down and say m plus 11, m minus 11. And we factored it apart. You could FOIL it to check your work. In this case, we could make a table off to the side, what multiplies to be 49 and adds to be 14. You probably already know what the answer is. But just to practice this perfect square trinomial, sometimes it will be easier to identify if you can take the square root of the first term, square root of the second term. Is the middle term 2 times that product? And the answer is yes. So since it is 2 times that product, then we're going to say the answer is r plus 7 squared. You don't have to worry about making a table and trying to find what multiplies. But in this case, it probably wasn't too difficult to do it either way. Your choice. Here's another one. You probably know what the answer is already. But I'm starting to notice 144, and I say, hey, I think that you can take the square root of. So I'm going to test both of these. Can I take the square root of that one? Can I take the square root of that one? The answer is yes. Now, what about my middle term? This sometimes helps if you write it down. Is my middle term 2 times the products here? I get 24 because 2 times 12 is 24p. Yes, it's 24p. So I can do my perfect square trinomial. But notice that this is a minus 24. So I have to say p minus 12 squared. Again, you can use the table, you can do it the old way, or you can use this shortcut. Next, we're going to start talking about solving using these strategies. Okay, you can use factoring to solve certain quadratic equations. You can't solve all quadratic equations this way because not every quadratic is factorable. A quadratic equation in one variable, that means it has only one variable. The a is not the variable, and a is a coefficient. X squared plus bx plus c, that's our standard form. If we're in this type of form, we can find the solutions to our quadratic equations, and they are called roots. So the directions might say, find the roots of the quadratic equation. What the roots mean is factor and solve. If the left side is in standard form, then we can try to factor it, and we can use the zero product property to solve that. In other words, if we have our two terms, x plus 5 and x plus 2, if they're going to multiply each other to be 0, I know that either this one is 0 or the second one is 0. If we have our two terms, a and b, and a times b equals 0, we can all think of two numbers. Think of two numbers that multiply to be 0. We can guarantee that either the first number you picked was 0 or the second number you picked was 0. So here, if you're going to be multiplying your two binomials, that either the x plus 5 was 0 or the x plus 2 was 0. And then you can solve it by doing the opposite. You've definitely done that before, but perhaps in the past you haven't understood why you did that. So let's try here. So we look at what multiplies to be 42. I can't take the square root of 42, so I know I have to do it with my table. And adds to be negative 1. I know that my signs have to be opposites, and my largest has to be the negative. So I'm going to do 1 and negative 42, 2 and negative 21, 3 and negative 14, 6 and negative 7. So 6 and negative 7 add to be negative 1. If you knew that without writing out the full table, great. Then you can just come straight up and say x positive 6, x negative 7. So now we see that it multiplies to be 0. So we're going to set both of these equal to 0. And those would be considered your roots of the equation. Okay, what are the roots? In this case, it's not equaling to 0. So for us to solve these like we have in the past, we need to subtract the 35 from both sides, so it does say x squared plus 2x minus 35 equals 0. Then if you're able to see that to multiply to be 35, you need a 7 and a 5, and the larger one has to be positive, that's a great way to factor, and you don't need the table. If you need the table to see what your options are, go ahead and use the table. We're going to set these both equal to 0. And now we found our roots of the equation. That's where this equation would cross the x-axis. They're called zeros, they're called roots, and they're also called x-intercepts. Okay, here we look at it. Now notice how this one only has two terms. If it only has two terms, it's not going to be done the same way. The only way that we've worked with the two terms is to do the difference of perfect squares. So, can you take the square root of the first term? Can you take the square root of the last term? If the answer is yes to both of those, and it's the difference, it has to be minus in between, then you have f minus 11, f plus 11. And that still equals 0. So now you're going to set both of those equal to 0 themselves. And those would be the roots of the equation, or the solutions, or actually the x-intercepts. Those are three words that all mean the exact same thing. Typically you would use the different words differently in a sentence. Next we're going to talk about zeros of the function. The x-intercepts of the graph are at P0 and Q0. Because the function's value is 0 when P equals 0 and Q equals 0, we would call P and Q the zeros of the function. It's the same exact thing we've been doing before. So we're looking for two values that multiply to be negative 28 and that add to be 3. We have 7 and 4 that multiplies to be 28. The 7 would have to be positive because your larger term's positive. We set those both equal to 0 still, and these are called the zeros of the function. In this case over here, you might notice that x squared is a perfect square root, 4 is a perfect square, the middle term is 2 times that product. So I know that I'm going to get x minus 2 squared to equal 0. So x equals positive 2 is going to be my 0 of the function. It's going to cross the x-axis at only one spot. You could say that it would happen twice, but it would not be a 4. Here you could do the same thing, or you could just do it the old-fashioned way and say what multiplies to be 25 and adds to be negative 10. They'd both have to be negative. So you would get x equals 5. You could write it twice if you like, but it's not really necessary. Here, when we're multiplying out to find our area, we know that length times the width equals area, and my length we could call x, my width we call x plus 5. Okay, and we know that the area is supposed to be 36. So by multiplying that out, we have to put this into standard form for us to be able to work with it. If this has two terms, an x squared and a 5x, two different parts that have a different type of x, an x squared and an x. Essentially, if this has a b term, you have to bring them all over to the same side. Then we can try to factor it, and we're looking for two values that multiply to be 36, but add to be a positive 5. So I know my answer is going to be negative 9, or it's going to be positive 4, Negative 9 is impossible in the geometry, so I know my x value would have to be positive 4. Okay, last example here. We have a rectangular garden. It measures 10 by 15. That tells us that the area is 150. You want to double the area of the garden by adding the same amount to both sides. We want an area of 300. So we're going to take x plus 10 and we're going to take x plus 15. We're going to add x to both dimensions. So when we look at area equals length times width, we currently know 150 is made up of 10 times 15. Well, we talked about doubling the area to get 300. So we're now going to say that our dimension of x plus 10 and x plus 15 has to equal that 300. Now notice how this does not equal 0. So the only thing we can do is FOIL this out. And then subtract your 300 to the other side. So 15x and 10x is 25x. Now you can subtract your 300 over to get negative 150. You could make your table, or you could think about what your factors would be that would help you multiply to be 150 and add to be 30, and that would be negative 5 and positive 30. It might help to make the table. Set each of these to 0, and you would get positive 5. Here you would subtract over to get negative 30. This is not a possibility, so 5 would be the dimension that we would have to add. 15 times 20 would give us our 300. That would double our area, and that would add the same amount to each of the original dimensions.